Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Rahillailia Khoirunnisa. My NIM number is 2018101010 and 0. Here, I along with my groups will introduce a little who is our idol class.
Hello, my name is Fitri Murtikasari, NIM 201810101057.
Hello everyone, my name is Iriene Nirwono, NIM 201810101038.
My name is Rini Alviana, NIM 201810101091.
My name is Mustafidatul Ilmiyah. My NIM number is 2.1.8.1.1.173. Carl Friedrich Gauss, original name Johann Friedrich Karl Gauss, born April 30, 1777, Brunswick, Germany. Dead February 23, 1855, Göttingen, Hanover. German mathematicians, generally regarded as one of the greatest mathematicians of all time for his contribution to number theory, geometry, probability theory, geodesy, planetary astronomy, the theory of function, and potential theory, including electromagnetism. At the age of 7, Carl Friedrich Gauss started elementary school, and his potential was noticed almost immediately. His teacher, Budner, and his assistant, Martin Bartel, were amazed when Gauss summed the integers from 1 to 100 instantly by spotting that the sum was 50 pairs of numbers, each pair summing to 101. Gauss left Göttingen in 1798 without a diploma, but by this time he had made one of these most important discoveries: the contraction of a regular 17 gun by ruler and compasses. This was the most major advance in this field since the time of Greek mathematics, and was published as section 7 of Gauss' famous work, Disquisitiones Arithmeticae. Johann Carl Friedrich Gauss is sometimes referred to as the Prince of Mathematicians and the greatest mathematician since antiquity. He has had a remarkable influence in many fields of mathematics, and is ranked as one of history's most influential mathematicians.
At just 3 years old, he corrected an error in his father's payroll calculation, and he was looking after his father's accounts on a regular basis by the age of 5. Gauss' first significant discovery in 1792 was that a regular polygon of 70 sides can be constructed by ruler and compass alone. Its significance lies not in the result but in the proof, which rested on a profound analysis of the factorization of polynomial equation and opened the door to later ideas of Gauss' theory. His doctoral thesis of 1797 gave a proof of the fundamental theorem of algebra. Every polynomial equation with real or complex coefficient has as many roots or solution has its degree or the highest power of the variable. Gauss' recognition as a truly remarkable talent took result from two major publications, 1801. Foremost was his publication of the first systematic textbook on algebra number theory, disquisition arithmetic. The second publication was his rediscovery of the asteroid Ceres. Its original discovery by the Italian astronomer Gauss in 1800 had caused a sensation, but it vanished behind the sun before enough observation could be taken to calculate its orbit with sufficient accuracy to know where it would reappear.
Gauss' intellectual abilities attracted the attention of the Duke of Brunswick, who sent him to the Collegium Carolinum at 15, and then to the prestigious University of Göttingen, which he attended from 1795 to 1798. It was as a teenager attending university that Gauss discovered or independently rediscovered several important theorems. Gauss gave the first clear expositions of complex numbers and of the investigation of functions of complex variables in the early 19th century. At the age of just 22, he proved what is now known as the fundamental theorem of algebra, although it was not really about algebra. The theorem states that every non-constant single variable polynomial over the complex numbers has at least one root. Although his initial proof was not rigorous, he improved on it later in life. What it also showed was that the field of complex numbers is algebraically closed. Unlike real numbers, where the solution to a polynomial with real coefficients can yield a solution in the complex number field. At the Academy, Gauss independently discovered both laws, the binomial theorem and the arithmetic geometric mean, as well as the law of quadratic reciprocity and the prime number theorem.
Gauss' dissertation was a discussion of the fundamental theorem of algebra. Gauss returned to Brunswick where he received a degree in 1799. After the Duke of Brunswick had agreed to continue Gauss' stipend, he requested Gauss submit a doctoral dissertation to the University of Hampstead. With his stipend to support him, Gauss did not need to find a job, so devoted himself to research. He published the book Disquisitionist Arithmetic in the summer of 1801. There were 7 sections, all but the last section referred to above being devoted to number theory. In June 1801, Zach, an astronomer whom Gauss had come to know 2 or 3 years previously, published the orbital position of Ceres, a new small planet which was discovered by G. Pizzi, an Italian astronomer, on 1st January 1801. Zach published several predictions of its position, including one by Gauss which differed greatly from the others. When Ceres was rediscovered by Zach on 7 December 1801, it was almost exactly where Gauss had predicted. Gauss' work never seemed to suffer from his personal tragedy. He published his second book, Theoria Motus Corporum Coelestium, in Sectionibus Conicis Solem Ambientium in 1809, a major 2-volume treatise on the motion of celestial bodies. In the first volume, he discussed differential equation, conic section, and elliptic orbits, while in the second volume, the main part of the work, he sought how to estimate and then to refine the estimation of a planet's orbits.
Gauss' contribution to theoretical astronomy stopped after 1817, although he went on making observations until the age of 70. His publications during the time include Disquisitiones Generales circa Serium Infinitum, a rigorous treatment of series, and an introduction of the hypergeometric function. Methodus nova integralium valores per approximationem inveniendi, a practical essay on approximate integration. Bestimmung der Genauigkeit der Beobachtungen, a discussion of statistical estimators and theoria attractionis corporum spheroidicorum ellipticorum homogeneorum methodus nova tractata. The latter work was inspired by geodesic problems and was principally concerned with potential theory. For much of his life, Gauss also retained a strong interest in theoretical astronomy, and he held the post of director of the Astronomical Observatory in Göttingen for many years. Thank you for listening. May all those we have shared be beneficial for all of us. Wassalamualaikum warahmatullahi wabarakatuh.